Imagine standing on the edge of a sheer cliff, surrounded by miles of empty air, and shouting a single time. In most places, your voice disappears immediately. But in certain deep valleys, your words return to you. Sometimes the response is faint. Other times it comes back louder, arriving minutes later, sounding as if a second person is speaking from across the void. This happens in specific geological formations with immense scale, like the winding river basins and towering peaks of the Himalayas. You need miles of open space between hard surfaces to create that kind of delay. When those delayed sounds return repeatedly, it breaks our intuitive understanding of how air and distance work. We experience an impossible loop of sound that feels as if it could go on forever. For centuries, people living in these remote regions refused to enter echoing canyons after sunset. They believed the mountains stored the voices of ancestors and spirits, repeating them back as a warning to the living. The ancient Greeks explained this by imagining a nymph named Echo. Cursed by the gods, she lost the ability to speak her own thoughts and could only repeat the words of others as she slowly faded into stone. Physics dictates a different reality. Sound is a physical wave, and physical waves require energy. They cannot sustain themselves without a power source, meaning every echo must eventually fade into silence. If magic isn't sustaining these voices, we have to look at the specific geological geometry required to convince our ears they are hearing something eternal. This is the baseline mechanic of a standard echo. An invisible sound wave travels through the air, strikes a single flat surface, and bounces directly back to where it started. These valleys use a much more complex geometry. Like a rubber ball ricocheting down a narrow, multi-walled hallway, a sound wave trapped in a canyon pings repeatedly between opposing rock faces. The material of those walls determines the echo's strength. Soft environments, like dense forests, act like sponges that soak up acoustic energy. Hard rock acts as a highly efficient mirror, preserving the wave's shape with every bounce. You can see this combination at Echo Point in Australia's Blue Mountains. The platform sits directly across from the sheer stone faces of the Three Sisters. To function as a natural acoustic mirror, a landscape must combine this massive scale with exposed hard surfaces. Without both, the wave dies on its first impact. When an environment meets all these conditions, it creates a specific acoustic effect called reverberation. Because a canyon is irregular, your original shout doesn't stay together. The wave splinters, with different parts taking slightly different paths off walls at varying distances. These fractured reflections hit your ears at slightly different times. Our auditory system is designed to isolate distinct sounds, but when these reflections arrive just milliseconds apart, that separation fails. The brain cannot distinguish between the individual waves. Environmental factors distort the signals even further. High humidity thickens the air, and temperature drops change the speed of sound, while wind currents physically push the waves off their original paths. Because your mind merges these 1,000 overlapping, distorted reflections into a single tone, you perceive the environment as if it possesses a voice of its own. No matter how convincing the sensation, no echo in any valley on Earth can actually last forever. Physics draws an absolute limit on the sound. Every time a sound wave collides with a rock surface, the impact creates microscopic friction. That friction strips away a tiny fraction of the wave's kinetic energy. This energy loss is inevitable. Mathematically, the wave's amplitude must shrink until the sound falls below the threshold of human hearing and vanishes. Understanding this limit changes how we view the mountains. The endless voices are actually a finite, predictable equation of energy moving through space. Nature utilized this acoustic geometry millions of years before humans. Humpback whales and other marine mammals use these same reflected waves to navigate and hunt across the vast darkness of the ocean. Modern science reverse engineers these biological blueprints. By calculating the timing of bouncing waves, we create reflection-based systems like radar and sonar that allow us to navigate the world's shipping lanes and map the unknown. We use these same principles to look deep underground. By tracking how waves reflect through solid mass, a seismograph can record subterranean movements and measure the intensity of earthquake tremors. Architects now mimic mountain geometry in our buildings. These undulating wooden panels in modern concert halls are designed to capture and amplify sound just like a natural canyon. Shouting into a valley is a direct interaction with a massive, natural mathematical amplifier. These geological blueprints are what taught humanity how to master the invisible world of sound.